ThermoFlo software package is an advanced modeling and simulation tool for efficient analysis and assessment of thermal management system capabilities. In a ThermoFlo model, a complex engineering system is replaced as a network of parts and flow paths. To construct a model, the user selects the desired parts from the library and places them on the canvas, connects the parts to define flow paths and various loops in the model, chooses a fluid for each loop by right-clicking on a node to insert a fluid icon, sets the known conditions, load cases, and performs the simulation. The fluid is defined by double-clicking on the fluid icon. The user can choose from the vast selection of NIST fluids library or optionally define a user-defined fluid. ThermoFlo can be operated in two modes, the standard mode and thermodynamics mode. The user can have flow loops based on different modes in a single system interacting with each other, but each loop can only be based on one mode. In thermodynamics analysis mode, a complex engineering system is broken into subsystems called components. Each component has its characteristic equations defining its thermodynamic and fluid dynamics behavior. Components can have multiple inlets and outlets. Each inlet or outlet of a component is identified by a thermodynamic endpoint. An endpoint may be inlet to one component and outlet to another. Components and associated endpoints may be connected in a path or a cycle using ideal connection bars. In the remainder of this video, we will discuss the standard mode. The thermodynamics mode of operation and mixed mode models will be discussed in a later video. In the standard or flow network mode, various subsystems are represented by flow bars in a ThermoFlo model. Flow bars are virtual flow devices with a single inlet and a single outlet. Various flow bars are connected to each other using endpoints. Endpoints are ideal connectors with zero volume and zero flow losses. Therefore, the possible associated losses must be taken into account by the connecting flow bars. ThermoFlo parts are completely customizable and, as I mentioned earlier, are selected from the parts library. As you see here, the parts library uses a tree structure for categorizing similar components. The user can create new parts by copying an existing part and making changes to its interface and behavior. There are three types of parts. Simple parts are the most common parts and are represented using a single entity. 3D parts represent the highest level of fidelity. They are solved concurrently using computational fluid dynamics and heat transfer. 3D parts are only available in TEsuite package, which is an upgraded version of ThermoFlo with variable fidelity analysis functionality. Complex parts are a collection of parts. They can have a number of simple and 3D parts in them, but they are shown on the screen using a single icon to keep the display organized and uncluttered. Double-clicking on a part icon results in opening the Parts Property menu. Here we have access to all the user variables for the part. Units are available for any variable on the drop-down Units list box. Clicking in any tab will open its section on the form. To change the look or behavior of a simple part in your model, right-click on the part and choose Open Type Definition. From here you can change the icon, port locations, user properties, the form layout, and various tables and functions associated with the part. These changes will be applied only to the part in the current model. To make permanent changes to a part, you must right-click on the part in the parts library and choose Modify Part and follow the same procedure and save. To view details of a complex part and or make changes to its definition, right-click on the complex part and select Open Detailed Model. This results in opening a tabbed form with all information relating to the current complex part. The Display tab shows the simple parts comprising the complex part. If the results were loaded, it would be shown in this window. Other tabs are for changing the icon, port locations, user properties, the form layout, and various tables and functions associated with the part. One of the main differentiators of ThermoFlo software is the ability to define any part's behavior using complex mathematical expressions. These expressions can be applied by utilizing tables and functions to control any part's behavior. Tables are used to define ranges for an independent variable, and functions are used to define the behavior in the particular range. The user can define the independent variable by entering any expression involving solver variables in the entire model. Here we are looking at the behavior for an orifice, choosing the ratio of the length to the throat diameter as the independent variable and assigning a function to describe the orifice performance in each range. Note that as you enter the function expression, the MathLook window shows the expression in algebraic form for ease in error checking. Also, the variables in a function can be any solver variable or alternatively taken from another function. Here, A12 represents the ratio of the throat area to the duct area and is taken from a function called A12.